Hello, can you all hear me?
Yes, can hear you.
Yes, madam, can.
Yeah, very good. Okay.
Yes,
Let
madam.
me introduce myself. I think most of you have not met me before. Okay. Cannot see me. That's why I purposely switch on my camera so that you can know that who is talking to you actually. Okay, my name is Susana. Okay, this is my name. Okay. You can call me Dr. Si if you want. Okay. Let me introduce myself. What else you want to know about me? Dr. Tiong was my classmate. We both are very good friends. We know each other since our first degree. Then we become classmates during our master degree. Then Dr. Izatu was my student. When I first joined Unimas, I think Dr. Izatu was my first one or second batch of the student under education of mathematics. Okay, Dr. Izatu, you see Dr. Izatu was my student, then you might think that I'm very old. Actually, I'm very young. Okay. Okay, any more questions to ask me before I proceed? If you come to campus, hopefully maybe next semester or the following semester when you come to the campus, my office is just a few doors next to Dr. Tiong. Okay, so when you look for Dr. Tiong, you can actually look for me as well because we are very close to each other. Okay, any more things that you want to know about me? That's it, or shall we start? Okay. I haven't taught statistics for quite some time actually, but it's quite fun to pick it up again. Statistics. I used to teach statistics almost every semester. Then I stopped teaching statistics for almost 4 years. Then I come back to this again. So you're actually the first batch of me teaching statistics after 4 years. Okay. Okay. My major actually is in operational research and also statistics. So any CS students here? Yeah, I'm under the CS. Okay. Okay. Let me. Hi, Kevin. Okay. Okay. Shall we continue? Yesterday I got conducted 2 sessions of tutorial. Okay. I need to switch on my camera because I worried that my line is not so stable. By the way, you already see my face, you know how I look like. Okay. So if you have any question, you can always unmute yourself and ask me any question. If you want to stop me somewhere, you can just stop me, unmute yourself, and we can communicate and discuss. It will be easier because because when we have the face-to-face lecture from the student's face expression, I actually can know how much you can understand. Normally, they will show me confused face expression, then I know where should I explain a little bit more. Okay. So now I cannot see your face. You don't want to switch on your camera. So if you have any question, just unmute yourself and ask me. Okay, I will leave the chat box here a little bit because I need a bigger screen. How about attendance? Attendance, they still try to solve it. Okay, we will see whether we can use the QR after our lecture. If not, then just let's forget about it. Okay, it's not so important anyway. Okay. Okay. So I think the last topic that Dr. Izatu stopped was discrete probability distributions. Okay, so statistics. A lot of you know statistics, but maybe you might not able to know that what is the usage of the statistics. So I will not follow the slide today. I will mainly explain what we're going to learn and how we're going to appreciate that. So once you have the concept, then it's very easy for you to pick up what we're going to learn today. Okay, so we finished the discrete probability distribution. Now today we want to go back. We want to go into the continuous probability distributions. What is a continuous? Continuous is when your data can be in decimal point. Previously, what Dr. Izatu discussed is a discrete. Discrete is when your data totally cannot be in decimal point. For example, number of humans, number of phone, number of car, which cannot be decimal point. That all under discrete probability distributions. So that already finished. So we want to move into the normal probability distribution today. Okay. Normal probability distribution is very, very important because most of the data fall under normal probability distributions. Okay, before we talk about probability, because I believe that most of you have learned this during your Form 5 or during your ASASI or during your matriculasi. So, but I found that a lot of students, when they come to university, when we want to do statistics again, they come to this Z-score, this bell shape, this chart again, this probability, but they do not know how can the data become a bell shape. Am I right? Do you understand? Normally we see when we talk about the normal probability distribution is about this bell shape thingy, right? So how many of you that actually know how can our data become a bell shape? If you know, you type me yes. If you do not know, you type me no. Do you actually understand how come the data can be in bell shape? Okay, so today I will give you one example to explain to you what is actually this bell shape. How can a raw data that we have can become a bell shape? And then what is the use of this bell shape? Why is it so important? What kind of question that we can answer from this bell shape actually? So I'll not follow the slide, okay? But we will come back to the slide, to the certain slide for this chapter, okay? So I will leave it for you to read it by yourself. Oh, I need to record, okay? Sorry. Okay. So when I follow the slide, I will give you one example to explain to you how we actually can form this bell shape from the raw data itself. Then what kind of question you can answer from this? Why is it so important? And then why we need a standard normal distribution, why the Z-score and so on. Okay. So I give you one example here. Okay, I need a blank sheet. So let us use this one. I give you one example here. Let's say now I have a data. Now I'm the statistician, okay? So I want to take the raw data. Don't get confused with the raw data and the Z-score. Okay, I will explain it here as well. Okay, I give you one example. Now I want to study the midterm exam performance of my TMF1874 students. Okay, we talk about the midterm exam. You just finished your midterm exam, right? So normally exam marks is, full mark is 100 marks. 0 mark is 0 marks. Correct? Not? Okay. So I want to see the performance of my students. So after I do the marking, I will collect all the marks for my students. Okay. Then I want to see how's the performance of my student. Every one of them. So I have the raw data. Okay. I have the raw data here. Or maybe I have to change to whiteboard. It's easier for me to explain. Let me share the whiteboard. Okay. Okay, can you all see my whiteboard now? Yes, huh? Okay, good. So we continue. So let's say I have a set of data. So this data is talking about the midterm exam. This data is talking about the midterm exam. So the midterm exam range from 0 to 100 marks. Okay. So some of my students get 60, some of the students get 70, some of the students get 82.5, and then the highest mark is 85. Okay, we just assume this is a set of marks. The lowest is about 35, and then we have 40, we have 41, we have 51, and so on. Okay, I have a lot of data. Let's assume make the example very easy. So we have 100 students. So far, so good or not? So this is the example, okay? Let's assume that we are the statistician, then we try to get the raw data, and then we want to make it into bell shape. How can I do it in bell shape, right? Okay, so now I have all this data here. So I want to sort out all the data from the lowest to the highest. Okay, then I can put in all this data into a table. Okay, so this table, I will put the marks here. Okay, the marks X and the number of students. So I said, okay, the lowest is 35. The highest is 85. So let's say I have 35 to 40. You very familiar with this data, this table, right? 41 to 40, let's say 45. So this is 36. Let's assume this is 36, okay? So you have all this until we have 80 to 85. So you have the number of students here. So you have like 2, 3, 4, all this until, let's say 2. You put your data into this form. So we have the very raw data, and then you do a bit of sorting, put into the table, you have this data. You're very familiar with this, right? If yes, you type me right. So far, so good? Okay. So now, how can we get this data? So when you have this table already, normally the students can put all this into a histogram. You know histogram? Everybody know histogram, right? So histogram will range the data from the lowest until the highest. So the lowest mark is 36. Then the higher mark is 85, let's say. So the 36, the frequency is like this. So it's like this, like this, like this, like this, like this, like this, something like this. So the middle one is about, okay? When I have all the data here, I can easily find the average marks. Correct or not? Easy enough? You sum up all the marks and then divide it with the number of students, you will get the average marks. So this is my average marks, which is the mu. So my average mark, let's say, is 60. Okay. Now, so far so good. You have the raw data, you put into the table, then you change it into a histogram. Correct or not? So far so good. Everybody? Okay. Then, okay, when you see the data, okay, because we only have 100 students, when you have 1,000 students, you have more precise histogram. Okay. When you set back, okay, when you sit back and then you look at the data, most of the data will come up with this bell shape. And this is how we get the bell shape. Okay. Now. So bell shape actually is a form of histogram data from the raw data. After you sort it out, you draw the histogram. And then when your data size is huge enough, we actually can make it into a bell shape. So now you understand? If you understand, type me understand.
Yes, madam.
Okay? So this is how you get your bell shape data actually. Okay, now you understand this thing already, right? So in statistics research area or analysis kind of job, there are all sort of data for you to analysis. There are midterm exam marks, there are student height, there are expenses, monthly expenses of the Malaysian every month. There is a height, weight, centimeter, kilogram, a lot. So all this data, this raw data in statistics, we call it as a X data. Okay? Okay. So now, I'm a mathematician, okay? I'm a mathematician. So you can tell me that you can give me all sort of data. Okay, so when you are not a mathematician, you will collect all this data and then you pass it to me. Okay, I will ask you, can you sort? I will ask you as a statistician. Okay, I give you a case now. So as a statistician, I ask you, can you sort out all this data in table and then put into histogram first? I said, okay. Then you will do according to mine. Then when you have all this data, you pass it to me. Okay. Then another person will come to me and say, Dr. Sir, can you look into this and that? Okay, I have a lot of things to do. Okay, so I will pass some of the case, some of the data to Dr. Tiong to analysis. So Dr. Tiong, Dr. Tiong is very, Dr. Tiong is very ego man kan. So he will say that, can you try to put this data into a standard form or not? Okay. Then we come up with another type of bell shape. It's called standard normal probability distribution. Okay. So this is the normal one. This is the non-standard. So this another one is called the standard normal distribution. Okay. We stop this thing a while for a while. Okay, I will come back to this to explain. Okay, we stop it here first. So far until this part you can understand, right? Let me assume that you can understand up to this. Okay. Then a lot of students will ask me, so what is the Z thingy? What is the Z score? Why we need the standard normal distributions? Okay, I give you one example. I give you one scenario to understand why the standard thing is very important. Okay, now we are Malaysian. When we go travel, when you do traveling, okay, before COVID, I believe some of you will do traveling overseas. Okay, so normally, what kind of currency, regardless where you go, what kind of currency that you will bring? Can anyone answer me? When you go to Taiwan, when you go to Thailand, when you go to South Africa, when you go to New Zealand, let's say you 1 year you travel a lot of country overseas. What country currency, what type of currency you will bring with you? I know foreign currency, but what is the standard one that normally you will bring? USD? Yes, a lot of you said USD. Now tell me, why USD? Can you explain to me why you bring USD? Why you don't want to bring ringgit Malaysia and go to that whatever country you go and then you change? Because USD is accepted worldwide. Because USD is standard. Because USD every country can use. Very good question. So the standard normal distribution is kind of USD in statistics. And then we need this standard thingy to let statisticians to talk to each other. When I look into a data, when the statistician they do analysis, they will not look into this form anymore. So this is in currency form, this is ringgit. Another person bring the data to me, maybe is bringing the Sing dollar. But when a statistician talk to statistician, for example, when I want to analyze this thing further with Dr. Tiong, we don't talk about ringgit anymore. We talk USD. So when we talk about USD, it's very easy for us to communicate. For example, now I have the midterm exam for this course, and then another lecture got midterm exam data for another course. So when we want to compare these two courses, right, we cannot use the raw data to analysis. We must transform the raw data into the standard USD model, and then we talk to each other by using USD. So this parable you can understand or not? I just want you to understand that why there is a normal standard deviation and why there is a standard normal distribution. Okay, so that is the reason why you use USD, and in statistics, we also have the USD kind of normal distribution. It's called standard normal distribution. Okay, so now we come back to here. Now we have the standard normal distribution, right? Okay, I change color first. Okay, so we come back to this. I can change this easily to the standard normal distribution. When I change to standard normal distribution, it's so much easier for me to do analysis. What kind of question you can answer for this? Okay, let's say now we go back to this raw data cases, the midterm exam marks. Now the decan said, okay, Dr. Si, you have 100 students here. We cannot give all the students A. Okay, you can only give 50% of your student A only. 15%. If you're not using statistics, how are you going to solve it? So you will sort the lowest until the highest, then you choose the highest 15 students. Am I right? Correct or not? If you can understand what kind of example that I explained to you, say understand. 50% A, 50% B. What's that? Okay, so by using statistics, when I put into the normal probability distribution, right, I can easily find 50% highest student. What is the mark? I don't need to sort out already. So I will just find that 50%. Okay, 50%, because all the data already sort out. So I can easily analysis. Then they can say, okay, any students that below 40 marks consider fail. Dr. Si, can you tell me how many percent of your students fail? Then I know, 40 marks. Okay, I will find where is the 40 marks. So everything that under 40 marks is considered fail. You understand me? So this is why the statistic normal distribution, when you put into the bell shape, is very important for analysis because they can answer a lot of what if questions. And then we want to see what is the chances of this thing happen. So that is why the probability coming in into the bell shape and the probability distribution. So far so good, everyone. Okay, I proceed. Okay, so now this is the raw data. I put it into a bell shape. So we call this as a non-standard normal distribution. I want to put it into a standard normal distribution. There is a formula. Okay, there is a formula. Just like, what is the formula? What is the currency rate for me to change ringgit to USD? There is a formula, right? So our ringgit divided by 4, currency USD is a bit high right now, okay, divided by 4. So this divided by 4 is a formula. So in statistics, when I want to change the non-standard to the standard, there is a formula also. And this formula is x z equal to x minus mu divided by standard deviation. So what is x? X is the normal data. What is the z? Z is the standard normal distribution. What is the mu? Mu is the mean, purata of the data. What is this? This is the standard deviation of the data, the raw data itself. Okay, before I proceed, can anyone answer me what is standard deviation? Use a very layman terms and tell me what is standard deviation. I know everybody know that what is average. Average is mean. I know everybody know what is average. Can anyone tell me what is standard deviation?
The closest value that deviates from the actual value.
The closest values? Again?
The closest value to the actual value.
The closest value to the actual values. Not so accurate. Any more? Differences between values. Okay. 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 The amount of deviation from how far between the values from and the mean. Okay. I give you one scenario for you to understand what is standard deviations. Hopefully what I'm sharing today will get your attention, interest to learn statistics. Because when we learn mathematics is somehow, people said that mathematics is a subject that very bored. So hopefully what I try to give you a parable that can attract your interest in learning, okay? So what is standard deviation? Okay, let's say now I have 100 students here, the midterm exam. So I close my eyes, I randomly pick 2 students, I compare the difference. I get the difference. For example, I get students that get 80 marks and 70 marks, so the difference is 10. So I put back these 2 students, I close my eyes again, and then I randomly catch 2 students, I check their mark and the difference. The difference, the average of each of the 2 pairs of marks, the differences, average is called standard deviation. Can you understand? Okay, so when your standard deviation is smaller, that means your data is more centered. So if your standard deviation is very high, the value is very high, that means your data is scattered around. So far, so good. So why just now I emphasize that I need to close my eyes to get 2 students, because in statistics, all the data that you collected to do study have to be randomly picked. So far, so good or not? Can you all understand me? Okay. So I assume that you can understand, okay? So this is the formula. Okay. Whatever X mentioned here is referred to your raw data. Whatever Z value here is considered the number at the standard normal distribution. Okay. Now, why we said the non-standard normal distribution, why we call the raw data is called non-standard, okay? Because the raw data that we collected, they have different set of mean and also standard deviations. For example, this course, I give 100 students to take this exam, they will give me different average mean values and also standard deviation. When I take another course, when I join the midterm exam, they will give me also the different number of the average and also standard deviation. Correct, no? But whatever data, after I convert it into the standard normal distribution, they have the very standard mean and also standard deviation, which is when it's Z, it's normal, the normal distribution is 0 and 1. It means that the mean here is always 0. And the standard deviation for this is always 1. This is the standard deviation. So standard deviation for this case is called sigma. So far so good. Okay, can I proceed? Okay, so now you know the bell shape. I know a lot of you learned the bell shape already. So again, I just want to complete it all. The area over here will bring you the concept of probability. So what is probability? Probability, normally in layman terms, it will tell you what is the chances that thing will be happen. So if I want to analyze something, so I want to look into the chances of how likely that thing to be happen. So if I get the probability is equal to 0.89, that will be equal to 89%. 89% means that the chances of this thing happen is very high. Or most of the students score a high mark or something. So what is the probability that this thing happen? Okay, so this is the area. Area means that the probability. Okay, this one cannot represent probability. In raw data, it cannot present the probability until you change it into the standard normal distribution. So far, so good, enough? So far, so good, enough? Okay, so in this chapter, what you need to do is that you need to understand how to read the table, okay, for the Z score. How you want to read the table so that you can get the probability correctly. I know that there's a software, there's an Excel, there is a internet, the Z score table that you can easily put it in calculator to get you the study, to get you the probability. It's very easy, it's very convenient, but it is useless if you do not understand the concept itself. Okay, so when I twist, you might not understand where is it, how is it, why is it. Okay, so it's still very important that you go back to the very basic. We go to the Z score table and then we try to understand it. Okay, so now, okay, let's assume that when we have this raw data, now we come back to this raw data. Okay, everybody, look at the screen. When you have this raw data, I can easily convert into it. So when I in the standard normal distribution, this 60 will become 0. All this number, okay, on the right side of the bell shape will become a positive number. All the numbers here, the Z score, the number here that less than the mean will become a negative values here. So we will know the positive and negative will always give me an idea. So you are now study the data that above average or below average. So that is the whole concept of the standard normal distribution. So far so good or not? If good, type me 1. Just to make sure you all don't fall asleep. Okay, now I will not go through the slide one by one, but I will straight go to the example itself. Okay, I will stop sharing. Then we go back to the slide. Can you all see my slide now? Okay, now, okay, we go to the slide 16. Okay, we try to read this, okay? I give you 10 seconds. Can you read this example question through? And then when you finish reading and understand, you type me 2. 10 seconds to read. When you're done, type me 2. Okay, very good. So, okay, so this example is talking about we want to analysis to find the probability as a result as reading less than 1.27. Okay, okay, now this data is a raw data, okay? Raw data, but coincidentally, this raw data has a mean of 0 and a standard deviation of 1. So we can directly use the Z-score. Z-score means that the standard normal probability distribution to do this analysis. So they say they randomly select an adult undergo a bone density test. Find the probability the result is a reading less than 1.27. Okay? Okay. So now, because this is 0 and 1, okay, we can straightforward use the table. So in the table that we have, all the area reading is covered from the accumulative area from the left. Okay, so now we want to have this 1.27. So here is, you always remember the middle one is 0. So here is positive, here is negative. So 1.27 is a positive one, 1.27. So anything less than 1.27, anything less than 1.27. So I can just go to the table and read 1.27. So let us go to the table itself. Do you have the table with you? Whoever that don't have, can you go to the ellipse and download it now? I give you 10 seconds to download it now. When you're done, type me done. I want you to open up your table. Okay. Then we want to get the reading, right? So anything on the first column and the first row, this is the Z-score number. The values, okay? The values over here. In the body itself, the body here is all the probability. Only the first row and the first column represent the Z-score. The one in the body is the probability. Okay, so now the Z table, you have two pages. One is referring the negative zone, the Z negative, which is area below the mean. So what is positive? So just now, the PZ less than 1.27. So it's definitely at the positive side. So we look for 1.27 is here. So this is the reading. So the probability to get the Z less than 1.27 is equal to 0.8980. As simple as that. So far so good. If good, type me 1. Okay? Okay. So we go to next example. This is just warm up, okay? So now I want you to do more another one, okay? Can you try to see whether you can get this figure from the table itself? So whoever that do not know how to read the table, you must make sure you have to check or ask your friend to make sure that you know how to read the Z table. If you do not know how to read the Z table, you're not going to score. You're not going to able to answer any question of these standard normal distributions. Okay. Okay, we go to next example here. Okay. Now, the probability of Z greater. Z is the standard normal distribution, okay? So the probability of Z, so always 0 in the middle, okay? Greater than negative 1.27. Negative, so it's on this side, negative. So negative 1.23. Greater than 1.23. So it's this area. Okay? But in the table, when I read, it only can come to here. When I read negative 1.27, they will only give me this. But this is what Dr. Su wants. So this is what table can give you. So how? You understand this? So to find the probability that Z score is greater than negative 1.23, so I will use 1 minus probability Z less than negative 1.23. Because the total area is always 1. Okay? Then you can get the reading from the table by using this. So far, so good. If good, type me good. So from the table, you can get the reading. What is the final answer? So the final answer is 0.8907. Okay, good. Then we go to, if you have any question, you have to ask me, okay? Stop me somewhere. Okay, now we come to this. You must write the statistics in the form that the table can read. Then only you can go and get the reading itself. Okay? So now, try. A thermometer is randomly selected. Find the probability that it's read at the freezing point of water. So the freezing point is 0 degree, right? Between negative 2 and 1.5 degree. How to do this? I give you about 10 seconds to think about this. Okay? Negative 2 to positive 1.5. The middle one is always 0, negative 2, and then this is 1.5. Okay, I want this area. Okay, but Rebecca, I don't know. We haven't come to that yet. You can try to solve it and tell me why. What is that? Okay, so this is what the question want. This is what the question want. They want the area, the scattered area. But in the table, okay, I can easily get the reading for this. Only this. Okay. Negative 2, this area from the table. And if I want to read, okay, this is 0, this is 0, 1.5, this area. When I get the reading from the table, I can only get negative 2, this area, or 1.5, this area. But I want, the question want this. So I will use this reading as a A. This is B. So I will use the reading from A to minus the B reading. Okay? So the final answer, I will leave this thing for you to try yourself. So the final answer is 0.9104. Okay. Okay. Can anyone tell me that what is the Z score value for negative 1.5? 1.5. I need to open up as well.
Is it 0.9332?
1.5, huh? Okay.
Yes.
0.9332. Okay. And then negative 2?
Negative 2 is 0.0228.
0.0228. Yes. So it's 0.9 something minus this 0.228. So you will get the probability. Okay. Okay. Done. So we go back to okay. Okay, so we go to next example. Okay, I give you a bit of time. You try to solve this for me, okay? You try to do 5 and 6 for me now. I only want 5 and 6. Question 5. 0. They want negative is here. Negative 0.85. Greater than negative 0.85, so it's here. Number 6. Negative to positive. Negative to positive. Negative is negative 1.85. Positive is 1.56. Okay. Okay, can anyone tell me what is the answer for 5? Zero 0.8023. Correct. Okay, number 6. Okay. Can I proceed? The rest you can do it and then check the answer with your friends. Okay, now I want you all to try to solve number 2 and number 4. Okay, when I come to this normal probability distribution kind of questions, whenever I can, I will draw the bell shape. I will draw the bell graph and I will put my zero mean line first. Then only I will do the analysis. Okay, now question number 2. They ask us to find the z-score. I don't know what is my z-score, okay? I know this is my 0. They asked me to find my z-score. But this is probability. And this probability is less than 5, less than 0.5, okay? Less than 0.5 means that the area that you want is definitely less than half. Okay, so they said less than. That means the area is somewhere here. And then they said it's 0.123. So it's very little. So it's somewhere here. Okay, and this is 0.123. So this is probability. So when you go to the table, you have to start to look into the tummy of the table and then go and read back the z-score. So when you look at the table itself, 0.123, okay, 0.123. You have to go to the z-score area 0.123. 123. It's equal to negative 1.16. Yes. So this is the z-score is equal to negative 1.16. Okay, done? Okay, then we go to the question number 4. Always start with the bell-shaped graph first. Okay, it's less than what? The area is less than. And then it's 0.85. 0.85 is greater than half. It's greater than 0.5. Okay, so we know that less than is somewhere here. Okay, is this area. They say it's more than half, so I have to get my shattered area more than half. So it's somewhere here 0. And this area is 0.85. Then you go to the table, 0.85, because it's a positive area already. So I need to get 0.85 somewhere here. Okay, so I can use 1.035. 1.04 is okay. 1.04 is also okay. So this one is Z equal to 1.04. So far so good, or not, everyone? Okay, all good, huh? Very easy. Okay, now I give you all 10 seconds to read through. When you're done, type me done. Okay, we give another 10 seconds for the other friends. Doctor, in this course, do we need to consider the third decimal point or just round out like question 4? Question 4 is only two decimal point, right? So you just do 2 decimal point. But we can actually, if you want to give me 1.035, is also okay. Normally, if your answer have a lot of decimal point, we keep to 4 decimal point at the final answer. Okay, now we come to this example. Everybody, can you put down your pen or whatever? Just look at the screen and listen to me. Just give me about 30 seconds for me to explain. We analyze this question together, okay? So all passengers in a water taxi are men. Assume that the weight of the men are normally distributed with the mean of 172 pounds and a standard deviation of 29 pounds. Okay, so I write it down. The mean is 172 and the standard deviation is equal to 29. Okay, so when I look at this question, I already know because the mean and the standard deviation is not 0 and 1. So this is from the raw data already. So when raw data, all the data is the X. Okay? Okay, they are not in the standard normal distribution form. Okay, so if one man is randomly selected, what is the probability his weight is less than 174? Okay, so what is the probability that he is less than 174? So we try to draw our graph. So in the middle here, okay, this is the raw data, the non-standard one, okay? So this is the mean. So the mean is 172. So they want to ask you, what is the probability that this man weight is less than 174? Where is 174? 174 is somewhere here, right? Correct or not? It's not in the middle. They want anything that less. You remember that our bell shape is always the data range from the lowest until the highest. You remember the exam mark just now, the 35 marks, we arrange the histogram itself until the highest of the marks of the student 85. Correct? No? So when you draw the number, the score, the X score here, you must remember it's always range from the lowest to the highest. Okay? Okay, now they ask you to find the probability. So if I'm not using the standard normal distribution, I cannot easily find the probability. Okay, so we must change it into the standard form. So what is the standard form right now is that I need to change this to exactly into the standard normal. So this is 0 and I know it's somewhere here. Now, the question asks you is 174. But for us, we do not know this is the z-score already. Okay, this is the, sorry, make you not to confuse. This is x, this is the z. But I don't know what is the z here. I cannot analysis. I cannot read the probability from the table. I do not know the z-score. So I want to use the magic formula to do the conversion, to convert the ringgit into the USD. So the formula is z equal to x minus mu divided by the standard deviation. So this is the magic formula to change from the non-standard to the standard one. Okay, I want the z-score, right? Okay, how to get the z-score? So what is the x that they want me to analysis? The x that they want you analysis is 174. So 174 minus the mu given 172 divided by the standard deviation of 29. So use your calculator and tell me what is the figure. 174 minus 172 divided by 29. So it's 0.6896. Okay, very good. Okay, you can use 0.07. Easier for you. Okay, now I know here is 0.07. Now I want to find the probability that z less than 0.07. What is this? Then I can read from the table, right? Very easy. So you can read from the table, which is 0. Anyone? When you read from the table, this is 0.5279. Very good. Okay. Everybody okay? If you're okay, type me okay. Okay. So, okay, you can stop typing. Okay, I just want to do a bit of summary here before we continue. Okay, so what I want to emphasize here, this graph and this graph, they are the same. Okay, this is just in ringgit form. This is just in USD form. Okay, they're actually the same values. They're representing the same data. They're representing the same value as ringgit into USD. Okay, in the ringgit form, in the ringgit world, this is 172. In this USD world, this 172 is 0.07. And in this USD world, all the number here is represented by the Z. In this ringgit world, the raw data, all the values that return here is the Z, is the X. So far, so good, enough. And this is the magic formula for me to change from ringgit to USD, USD to ringgit, which is non-standard normal distribution to the standard normal distribution. I can also change from the standard normal distribution to the non-standard normal distribution. Understand me? Okay, one more thing. So in a question, they asked me to find the probability that X is less than 174. This is equivalent to find the probability of Z score less than 0.07. These two, they are the same. Can you understand? If you understand, type me Sam. Okay, so now what I want you not to get confused is that what is X? When you're talking about the X, we refer to the raw data. So it's very hard for you to do analysis when you're in a raw data. If you want to answer what if kind of analysis question, it's very, very difficult. Until you can find the mean and the standard deviation, we can twist into the standard normal distribution, then it's very easy for you to do analysis. So the Z is the standard normal distribution. So far, so good? Okay, now I want to test on you. What is the mean and the standard deviation for the standard normal distributions? I repeat, what is the mean values and the standard deviation values for the standard normal distribution? Mean is 0 and the standard deviation is equal to 1. Very good. Okay, so now you understand? Okay, now I proceed. We proceed to this. This is the slide 36. Okay. Okay, no need. We change to this one. Okay, now I give you 10 seconds, 15 seconds. Read this question. If you done, type me done. Will they ask us terbalik? Like find the row 1 instead of standard 1? Yes. You can always change it by using the formula. Okay? Okay, we give another 5 seconds for some of your friends. Okay, let's read it together, okay? Farmers often sell the fruits and the vegetable at the roadside stand during the summer. One such roadside stand has a daily demand for tomatoes per day with the mean daily demands of 125. So this is the mean, 125, and the standard deviation is 28, okay, per day. So if there are 99 tomatoes available to be sold at the roadside at the beginning of the day, what is the probability that they will be all sold? Okay, so we draw this. What is the mean? So I draw the x1 first, okay? What is the mean here? 125. Okay, so this is the mean. Mu is the mean. Okay, now they want you to analyze 99. What is the chances that 99 tomato will be all sold out? Where is 99? 99 is here, right? Okay, now I want to ask you. So they want me to find the probability. Okay, probability, right? So the probability can be this area or this area. This is the A area. This is the B area. Okay, now tell me, from this question, I should take the probability of A or B? Why not A? Because we want to get the probability that we have more demand. So it's a B area, correct? Not? So the probability is equal to Px is greater than 99. When this is the X, why is X? Because it's a raw data. Okay, raw data is like this. The number pelik-pelik one. Okay, the number is pelik-pelik one. Okay, so when I using the raw data, I cannot read the probability from the table itself. So I must change this X to the standard normal distribution. So I need to use the magic formula. So it's PZ, okay, greater than 99 minus the mu, 125, divided by the standard deviation of 28. So this is the PZ greater than negative 0.93. Okay, can you read from the table already? Okay, so when I draw, because from the table we can only read the A area, we cannot read the B area. So I will use 1 minus the A area. Okay, so it's 1 minus 0.1762 equal to 0.8238. Okay, everyone?
Doctor, can you please explain back why is it the B area, not the A area?
Okay, okay. You have 99 tomato that you want to sell, right? What's the probability that they will be all sold out? Okay, so these are the number of the tomato that normally they sell per day. Okay, some of the day we will sell 125, some of the day we will sell 150, some of the day we will sell 160. Let's say here is 150 and 160. So some of the day I don't have a lot of customer, I will get 50 only. Correct not? To make sure my 99 tomato are all sold out, okay, I have to make sure that the days that I have more than 99 customer want to buy from me. Correct? To make sure that 99 tomatoes are all sold out, I have to make sure I have more than 99 customer want to come and buy the tomatoes. Correct? Can you understand?
Okay, I understand that.
Okay, so it's not A because A will be less than 99 customer come and buy the tomato from me. Then I cannot make sure my 99 tomatoes will all sold out on the day itself. Okay. Okay. Now we move to this one. Next questions. So, okay. Okay, spend some time to read this. Okay, this will be more likely as your final exam questions already. Your final exam will sounds like very similar to this. Okay, we try to do question A first. Inch is inches ka? Yes. Okay, I give you about 1 minute to try to do question A. Okay, can we continue? Okay, so this is the following information to, this is the information that you have. We have two set of data here. Okay, one is the man, the other one is the woman. Okay, the man height is slightly higher. Okay, the man height is 69 inches and a standard deviation of 2.8 inch. Then the woman is a bit shorter. The mean is 63.6 and the standard deviation is 2.5. So now they have a standard casket, okay, with the height is 78 inch. Okay, so on average, everyone can go in, right? Because the average height is 69 and 63 for women. On average, we can see that everybody can go in. But is that in the rear that we can fit in, or we do not know? So they ask you, what percentage of the men is too tall to fit in? How many percent of the men are too tall to fit in into this casket, and then what the percentage of the women they are too tall to fit in? That means they are too tall and then they cannot go into the casket. Okay. Then from the percentage, can you tell us, is this height is adequate enough to accommodate everyone, including the tallest man and the tallest woman? Okay. Now, what is this? Okay. We go to this, okay? We analysis this, and we want to know that how many men can do this. We try to solve the man first, okay? So the man, the mean is 69. Then the standard deviation is 2.8. For the woman, the mean is 63.6 and the standard deviation is 2.5. Okay, so the casket height is 78 inch. So for the man first, we try to do the man first, okay? The probability for the man, we want to see what is the percentage that man, the height is more than 78. Then I want to find the probability of the woman, the height is greater than 78. Okay, I give you about 30 seconds and try to do this for me. This is very straightforward already, right? We cannot read directly, so I have to change the X to the Z table. So is Px Z greater than 78 minus 69 divided by 2.8. This is the Pz greater than 78 minus 63.6 divided by 2.5. So this is the Pz greater than 5.76. This is the Pz greater than 3.21 greater than 5.76. Okay, so you got this probability is 0.007, and then for the woman is 0.0001. So if we convert this, is about not even 1%. Okay. Okay, so it's 0.07%. So this is 0.01%. Not even 1%. So it means that it almost can accommodate everyone. Okay. Okay. So how do we answer this question, whether this casket is adequate for them or not? So it's adequate actually. Okay, now we go to the question B. A manufacturer of the casket want to reduce the production cost by making a smaller casket. 78 can accommodate everybody, okay? So what is the inside length would fit all men except the tallest 1%? So we want to know that what is the height that we want only 1%. Okay, just now who asked me that they might ask the reverse question. So this is kind of reverse question already. Okay, this is the man. Okay, so now we want to see how to get that 1%. Anyone want to try? So the area is like this. This is 0.99. Okay, 0.99. So I want to know what is the z-score here. When I get the z-score, I can easily convert it into x. So 0.99, can you read it from me, the table? What is the z-score here? If I read from the table, the z-score is about 2.33. Correct? Yes. So your z-score is 2.33. By using the formula, z is equal to x minus mu divided by standard deviation. So this means that 2.33 equal to x, which I do not know, minus the standard deviation is 60. The mean is 69, and the standard deviation is 2.8. So I can easily find the x is 75. It means that any man that above the height of 75.5 is considered the tallest 1%. So this manufacturer, they do not need to build the casket up to 78 inch, but they just enough to go for 75.5 inch to accommodate 99% of the men. So these are the questions that you can answer by using the normal distributions. Okay? So far so good, everybody? Yes. Okay. So if do you have any question to ask me? Anyone? You can unmute yourself if you want to ask me. Okay, thank you for converting the inch into the centimeter. Okay. So after we finished the lecture already, so you can go back and try to do your tutorial questions. Then next week you will see your lecturer from each of the group, and then make sure you try all the tutorial questions. Make sure you can answer. You try, then you will know which part yet you do not understand. Okay? No more question, then I will stop here. I will see you guys next week. Okay, no attendance, QR attendance, because I was informed by Dr. Tiong, they're still troubleshooting it. So I'll see you guys next week. Bye. Take care, everyone.
Thank you, Madam. Bye.
Bye.